Welcome to the deep dive. Okay, so you, the learner, want to get your head around IT infrastructure,
Uh-huh.
but, without getting totally overwhelmed.
Right. Just the essentials.
Exactly. So today we're hitting the core parts, how IT actually works, from the physical gear right through to the networks connecting it all.
Yeah, and our mission really is to pull out the key insights,
Yeah.
especially around hardware and networks.
And then maybe connect that to why outsourcing IT is so common now, and things like SOC too.
Makes sense. It all ties together.
Okay, let's start with the tangible stuff then, computer hardware.
The physical bits.
Yeah. Think about like your own laptop or maybe a tablet. Those are what we call end user
The
devices.
things you actually interact with, right? At the network edge.
Right, but then there's all the infrastructure behind that, servers doing the heavy lifting, switches, routers, that kind of thing.
The gear used by the folks who build and maintain the network. It's a different category.
Definitely. So one's for using, the other's for, well, enabling the use. And, inside your own device, you've got the basics. Microprocessor, the brain, RAM, short-term memory, storage,
Yep. The core internal components.
and then the external things.
Mm.
Your mouse, keyboard, maybe a printer, peripherals.
Uh-huh. But don't forget the actual place where a lot of the back-end hardware lives.
Oh, good point. Data centers or even just secure office rooms.
Yeah, with proper security, climate control, it's easy to overlook, but critical.
Absolutely. Okay, so that's the hardware. How does it all talk to each other?
That brings us to network infrastructure.
Right. The hardware, software, the layout, the rules, everything that lets devices connect.
So you start with things like modems. That's your gateway to the wider internet, usually,
Okay. The doorway,
pretty much.
Yeah.
Then routers, they're like traffic controllers.
directing the data packets.
Exactly, making sure data goes to the right place efficiently. Then you get switches.
Ah, like a power strip for the network.
Yeah.
Lets you plug lots of devices in.
Good analogy. Yeah, connecting multiple devices within the same local network.
Okay. And gateways, you mentioned those too.
Right, gateways are kind of like translators. If you have two networks using different rules, different protocols, a gateway helps them communicate.
Okay. Like TCP/IP, you're talking to something else.
Potentially, yeah. And we also hear about edge devices now.
Doing more processing closer to the user.
That's the idea. Faster response times sometimes. And of course, servers are still central, managing resources and information.
Got it. So it's quite a system.
It really is a coordinated effort.
Now, keeping all this communication safe.
Yeah.
That's crucial. Firewalls, right?
Absolutely essential. Think of them as digital security guards.
Standing at the network entrance, checking IDs.
Sort of. They enforce predefined security rules. They look at data packets and decide whether to let them through or block them based on those rules.
Okay. Are there different kinds?
Oh yeah. Basic ones might just filter based on source and destination addresses, ports, that sort of thing.
Simple checks.
Right. But then you have more advanced ones, like next-generation firewalls. They can be much smarter. They can understand which applications are generating the traffic, maybe even which user, so they can apply more granular rules.
Ah, much more sophisticated control then.
Definitely. They're a key part of network defense.
Okay, so we have the devices, the connections, the security. What about the actual physical layout? Does that matter?
It does. That's called network topology,
Yeah.
the physical arrangement of the nodes and connections.
Right. I think I've heard of a few types, like bus.
Yep. Bus topology. It's simple, like all devices connecting to a single main cable. But if that cable breaks,
Everything goes vulnerable.
exactly, then there's mesh.
Lots of connections, right? Everything connected to everything else, potentially.
Well, often many redundant paths, yeah. More resilient, like you see in some wireless setups, but it can get complex and expensive.
Okay. What else? Ring.
Ring topology. Data travels in a circle from one device to the next. Minimizes collisions, but can be slower if it has to go all the way around.
And the last common one is star.
Star topology. Probably the most common in LANs today. Everything connects to a central hub or switch.
Easier to manage, maybe. If one cable fails, only one device is affected.
Generally, yes. But the central hub itself is a single point of failure if it goes down.
Then the whole section network is down.
Right, so the topology choice impacts performance, reliability.
Big time. There are always trade-offs. Cost, complexity, resilience.
Okay, this makes sense. But how does the data actually move? Like, what are the rules of the road?
Protocols. Network protocols are the agreed-upon rules and formats that govern how data is transmitted and received.
Like a language computers agree to speak.
Exactly. And there's a model often used to understand this, the OSI model, Open Systems Interconnection.
7 layers, right? Sounds complicated.
It can seem that way, but the idea is to break down the communication process. Each layer handles a specific task.
Can you give us a quick sense, like sending a letter? Kinda. Layer 7 application is where your app creates the data, like writing the letter. Lower layers handle things like formatting, presentation, managing the connection session, ensuring reliable delivery, transport, addressing and routing network, preparing for the physical wire data link, and finally, the actual sending of bits, physical.
Okay, so data gets wrapped up as it goes down the layers.
Yep, that's encapsulation. Each layer adds its own header information. Then it gets unwrapped, decapsulated at the other end.
And specific protocols work at different layers, like HTTP for web.
Right, HTTP is an application layer protocol. TCP and IP, the backbone of the internet, operate mainly at the transport and network layers.
Got it. So the model helps understand how communication happens step by step.
Precisely, it's a framework.
Okay, almost there. What about the big picture, different types of networks overall?
We talk about network architecture. The most basic is a LAN, local area network, like in your office or home.
Cell scale.
Yep. Then WANs, wide area networks, cover much larger geographic areas. The internet is the ultimate WAN.
Makes sense. I've also heard of SD-WAN.
Software-defined WAN. It uses software to manage and optimize the WAN connections, making them more flexible and efficient than traditional WANs.
Okay, using software smarts and VPNs.
Virtual private networks. They create a secure, encrypted tunnel over a public network, like the internet. Great for remote access or connecting offices securely.
Right, for privacy and security over insecure connections.
Exactly. Tailored solutions for different needs.
Wow, okay. So you can really see how it all connects. From the laptop in your hand, through switches and routers, across different network types using specific protocols, all protected by firewalls.
It's all deeply interconnected.
And understanding these fundamentals, even at this level, it really provides a solid base, doesn't it? Especially now.
How so?
Well, like we said at the start, so many organizations rely on outsourced IT functions now. Cloud providers, managed service providers.
You're not always managing your own servers or network gear directly anymore.
Exactly. And that's where understanding this helps you appreciate why things like, say, SOC2 reports are so important.
Right. SOC2 is all about making sure those third-party service providers you rely on have the right controls in place for security, availability, confidentiality, and so on.
It's about trust, but verified trust. Knowing that the infrastructure you don't control is still being managed properly and securely.
Absolutely critical. As we depend more on these external services, verifying their practices through audits like SOC2 becomes non-negotiable, really.
It ensures that reliability and security we need. Okay, great overview.
Hopefully it clears things up a bit.
I think so.
Okay.
So let's leave you, the listener, with a thought, considering those network topologies we talked about.
The bus, mesh, ring, star.
Yeah, thinking about the real world, when would a mesh network, with all its redundancy, be a much better choice than, say, star network, and why?
That's a good one. It forces you to think about where resilience is absolutely paramount.
Exactly. What scenarios really can't afford any interruption? Something to mull over.